Hello everyone. I am Uttam Satpute, a professor in Electrical Engineering Department at D.Y. Patil Pratishthan College of Engineering, Saurabh. This is video number 4 on Unit 6 Traction Moment and Energy Consumption of the subject Electrical Generation and Utilization of 8th semester. In this video, we shall solve some numerical on speed time curve, and this is the first numerical we have taken. So let us first read the problem. Now the train. Now I will solve this problem in three steps. The first step, it is, let us find out what are the inputs, given inputs as per the given problem, and then we'll see second step, that what equations we are going to use to find out the unknown parameters, and third one I will write the to find out. So let us solve this problem into three steps. So let us first write the given data according to this given problem. Here it is given the schedule speed. It given the schedule speed. So let us write it as Vs. Vs it is given schedule speed. It is given as 30 kilometer per hour. Kilometer per hour. Or a level track distance between stations. So distance between stations it is given. So let us write it as yes. Yes, it is equal to 1 kilometer. Okay. I am using the notations as per the book in the GB Gupta. Then let us write the stopping time. So stopping time, let us denote it as TS, the stopping time. It is given as 20 seconds. Then the third parameter, now the next parameter is a braking retardation. So braking retardation, it is beta value. It is given 3 kilometer per hour per second. Maximum speed. So the maximum speed, which is VM, we call it as VM, it is 25% greater than the average speed. So we can write it as 1.25 into average speed. Average speed we have taken it as Vs. Okay, so Vm is equal to 1.25 times Vs, 25% greater, so we can write 1.25. Calculate the acceleration to run. So now what is asked? Let us write what is to be find out. So it is said acceleration required to run the service if the speed time curve is approximated by trapezoidal curve. So now we have to find what is alpha for all this data given. Now, what are the equations we have to remember? So, the first equation we have to remember, it is of Vm. So, Vm, we have to remember this equation. So, Vm, it is given by this equation. So, here it is written Vm square and okay. So, Vm, it is given by Vm square. So this equation I will write you to here. You note down this equation here. So this is the equation what we have to use. Okay. So this is given already. We have derived this equation. This is a quadratic equation that we have derived for trapezoidal speed time curve. So I'm using this equation. Vm square 1 by 2 alpha plus 1 by 2 beta minus Vm by t plus 3600 is equal to 0. So this is the equation what I am going to use here. Okay. Now let us start from the beginning. So now in this equation, what all things we require? Now first we require, now what we have to find out, this is what we have to find out, alpha. Okay. Now what all things we should know? First we should know Vm. Okay, so now Vm, you can see here already he has given Vm equal to 1.25 Vs. Vs already given as 30. So first you find out Vm. What is Vm? Vm equal to 1.25 Vs. So we have to find out. So Vs already given 30 and 1.25 25% more than the average speed. So Vm. So this value we get it now. So Vm we got it. Beta is already given in the equation 3. Then Vm is known T. Now T is not known, which you have to find out. Now the how you can find out this? So we can use the average speed equation. What is average speed equation? Average speed equation is Vs, which is equal to S divided by time plus stop time. So this is what we have to find out. So now I'm using this equation. So using this equation, Vs equal to S. S is already given, so I can use 1 kilometer. Uh, Vs is already known, and Ts it is given 20 seconds, so we can find T value. So use this T value over here, and then S is already given. So yes, it is given as 1 kilometer. So knowing all the parameters, only the parameter which you have to find out is alpha. So alpha can be find out from this equation. So here it is, finally they have find out this value of alpha, which is 1.8 kilometer per hour per second. Okay, so this is very important equation in trapezoidal time curve. You have to remember this equation. All the problems, whichever numericals they ask, this is based on this equation. Okay, so here all the parameters again you remember. This is the maximum speed. This is the acceleration. This is the retardation beta value. Vm is that t is the total time during between the stop, and s is the total distance covered between start to stop. So this is a simple problem. Now the next problem, it is very similar to previous problem. Only the difference here. Let us see what difference is there. Let us understand this problem first. So first I will write the input. Okay. Then we will see what equation I'm going to use, and third, then we will see what we are going to find out. Let us write the inputs. So the inputs what are given here, maximum speed. Now you can see here maximum speed is given. So Vm is given, it has 70 kilometer per hour. The scheduled speed including a status stop of 30 seconds. So Vs is already given, Vs is also given, that is the average speed. Okay, and what is the equation for Vs speed? We'll see. So this is given, I will write this value, it is 70 kilometer per hour. Please take care of the units. Okay, 30 kilometer per hour, and then scheduled speed it is 30 seconds. Oh, sorry, it is 45. Average speed is 35 kilometer per hour. Then including the scheduled speed, including station stop. So TS they have given it as 30 seconds. If the acceleration, now here we are given alpha value. Alpha value is 1.5 kilometer per hour per second. Find the value of retardation. Now they have asked beta value. So in the previous problem they had given beta value and they had asked beta value. So now this beta value I will write down here. So we have to find beta value. This is what we are required to find. Okay, and when the average distance between the stop. So yes is also given. Yes, distance between that is 4 kilometer. So knowing all these parameters, now we have to find out beta value. Now what is the equation? The equation is same. That is trapezoidal speed time curve equation. So Vm square 1 by 2 alpha plus 1 by 2 beta. Now what all things are given? Vm is already given. Okay, alpha is given. We can use directly. Beta, this is what we have to find out. The Vm is given T. Now T we have to find out. Only the thing with what equation we can use. So we will use the equation of Vs. Every speed it is equal to total distance divided by time between the stop and the stop time. Okay, so we can use this TS is already given. So VS is known, VS is already given, S is given. So we can find out this T. So find T, substitute over here in this equation. S is given, so we can find the beta value. that is retardation. So this is very similar to the first problem. Now let us go to the third problem. Now here also note down, let us first note down the inputs, what inputs are given. So I will write first the inputs, what all given. Now the electrical train has to have an acceleration and braking retardation. So both two values they are given. Alpha value, it is given as zero point 0.8 acceleration. Retardation beta value is given 3.2 kilometer per hour per second. Okay, then if the ratio of maximum to average speed, so now this is given as Vm to Vs. So this ratio is given, which is equal to 1.3. Means maximum speed is 30% more than the average speed. This is what they want to say. And time for stop Ts, it is given as 20 seconds. And then final scheduled speed. So Vs is also given 1.5 kilometer. Assume simplified trapezoidal speed time curve. Uh, so what we have to find out here, if the ratio of maximum speed and time for stop, find the scheduled speed. So okay, we have to find out the okay, I will write down here what we have to find out. So we have to find out schedule speed. We have to find out Vs. This is what we are interested in. So again, what is the equation? Again, the same equation of the trapezoidal speed time curve. This is the same equation we are going to use. So here in this equation, okay, now what all things they have given? VM, it is in terms of now VS. We will get it. It is not directly available here. Okay, so what you can do, VM, both the things are not known. So VS, sorry, find for a run of 1.2 kilometers. So yes is given. So this is not here. Yes is given. Yes. Okay. So what we can do over here, now we have to first what we will do, uh, VM, which is equal to 1.3 Vs. But how you calculate Vs? Yes, divided by. Okay, this is not scheduled speed, it is average speed. So it is, I will call it as average speed. VA, I will record it average speed, sorry. The average speed, VM by VA is given 1.3, not scheduled speed. Vs we have to calculate, yes, correct. So now VA, I will write it as VA. So 1.3 VA I can write it as into S by T. Okay, yes is already given. T, oh, it is not known to us. So that is what is we have to find out. What is the T value? T value we have to find out. So what we will do here, this VM, whatever it is there here, we can substitute this over here in terms of T. In terms of T, you can substitute. So this is a function of T you will have, because already all the parameters are known. Alpha and beta are known. VM, now here also we can VM we can substitute in terms of T. We can substitute in terms of T, and this yes is already known, so there is not an issue with that. So the entire equation now it will become in terms of T. This entire equation we can convert into in terms of T, and T we can find out. So this is how they have find out the T value over here. I think yeah, here I think when you I think here only they have done the substitution of T, not here. Here they have not done, so they have substituted VM over here. VM, yes, correct. 7,000 here. What they have the value 7,020 by T. So this T get cancelled. Then T parameter will cancel out only. Then we can find out this VM. VM they find out first. Then they have find out the average speed, and then they have find out the actual time. Now from the actual time, now scheduled speed, we know that it is s divided by t plus stop time. Stop time is already given 26 seconds, so t, once you get 154 seconds, we can use it here, and you can find out its scheduled speed. So this is a little bit complicated problem. Only complications it is because there are two parameters which are not known in this equation. So one is Vm and T. So what they have done, Vm they have substituted in terms of T, and they cancelled it out. Then they find out Vm. That is only logic what they have used in this problem. Okay, so this is the numerical which which they may ask for you. Okay, thank you very much.